is the bottom of page 2 of the study guide for benchmark number 2 for algebra. Let's take a look at this one here. We're graphing lines still. Last time we did the xy-intercept method. Now we're going to end up using the slope-intercept form. So when we're using slope-intercept form, we use this method when y is by itself. And it works really well. It's fast. It gives us lots of points. The number where we take x out of the equation, like you set x equal to 0, and you cover this term up, y equals -4. This is called our y-intercept. You find the y-intercept the same way you did on xy-intercepts. You cover up the x term. Whatever's left over is what the y-intercept is. So going down 4 spaces, 1, 2, 3, 4, putting a dot. Now use the slope. The slope of the line is 3, so slope equals m. I use the variable m for slope because m is like, stands for mountain. A mountain has slope. So I treat the slope as a fraction, 3 over 1. So 3 represents the rise, and the 1 represents our run. And so we're going to end up going up 3 spaces from this y-intercept. 1, 2, 3, and then over 1. Make sure you go spaces. So 1, 2, 3 spaces over 1. Do that again, 1, 2, 3 over 1. And then from there we've got lots of points. We can draw a line through. So just some practice on that. Here's another type. We've got the y-intercept again is what we have when we set x equal to 0. Notice that we're using this method when y is by itself. So y is all by itself, so that's when we can use this. So we put the y-intercept there and then use the slope. Here's the slope. -2 over 3. So this tells us to go down 2, and we end up going right 3 spaces. That's what the slope tells me to do. So down 2, right 3. Down 2, right 3. We could also go the other way. Could go up 2, left 3. Gets you on that same line. Up 2, left 3. And then you have a bunch of points to be able to draw a line through. Well, we've got another one that looks a little different because we don't see a number being added to the x term. Well, you could always put a 0. Adding 0 to a number doesn't change anything. So that's our y-intercept. And what's the slope? Don't see a number in between the minus sign of the x. Well, you can always put a -1 there. So -1 over 1. So it means down to the right, down to the right, down to the right. Or you could go up to the left. Gets you on that same line. And then from there you can draw the line between those points. Well, looking at the next one, we've got a y-intercept of +1. So you just go up 1 space and then use the slope. Slope of this line is 2 to 1. So up 2, right 1. Up 2, right 1. Could also go down 2, left 1 on that same line. And then from there you draw the line between those points. And there it is. Well, those are slope-intercept forms. Let's take a look at some inequalities. We talked about having to do those. And I even give you the rule about what to do to shade. Remember, less than or greater than, we have a dashed line. Having the line underneath means the line equals, so that's why it's a solid line. Positive y greater or greater than or equal to is above the line. Positive y less or less than or equal to is below. So let's take a look at this first one. Use the slope-intercept form to graph it. We'll start with that -1, and we'll just go down 1 space. So again, the y-intercept was -1. Going down 1 space, putting a dot. Then use the slope, 3 to 1. So we're going up 3 spaces, 1, 2, 3 over 1. Up 1, 2, 3 over 1. You could also go the other way, down 1, 2, 3, 1 to the left. Gets you on that line. No line underneath, so it's a dashed line. And then from there, we need to figure out which way to shade. Well, positive y is greater. That means the y values are bigger. We need bigger y's. Where are the bigger y's? Well, go to any point on this graph. The bigger y's are up this way. They're up this way. So that's the direction that we'd end up shading on this side of the line. Let's take a look at another one. Another chance to practice this. +2, the y-intercept. And the slope is -1 to 2. So down 1 over 2 to the right. Down to the right. Down to the right. Or you could go up 1, 2 to the left. Up 2 to the left. Up 2 to the left. And then from there, we draw the line. This time it's a solid line, so that means it's a line underneath means solid. And that means that the points on the line are solutions. That's why we draw that solid line. Now, which way do we shade? Well, positive y is less. Less means smaller. So we want smaller y's. And so smaller y's, well, if you put any point anywhere on this line, like if I'm right here, smaller y's are this way. Smaller y's are this way. So that's why we end up shading below this line. Well, we'll get another chance to practice here. This is a good one for xy intercepts because x and y are on the same side. You could also subtract the 3 and use slope-intercept form, either way. Well, here I have 3x is greater than or equal to 3. So that means x is greater than or equal to 1 when I solve. So 1 is the y-intercept, or x-intercept, sorry. Now from there, I need to find the y-intercept. Well, it's already given to us. Y is greater than or equal to 3. So I go up 3 spaces, 1, 2, 3, put the dot, draw the line. It has the line underneath, so it's a solid one. And then I got to figure out the shading. Well, either of these two will tell you. X is greater than 1. So go to any point on the line. Let's start at this point right here. Greater than 1 means this way. Those values are bigger than 1. See, if you started here, same thing. Greater than 1 means that way. The y-intercept also tells you. So y is greater than or equal to 3. Greater means bigger. Bigger y's are off in that direction. They're above the line. So that's why we end up shading here. Over here, this one here, we could do xy intercepts again. 2x is less than or equal to 6. So x is less than or equal to 3. Y would be negative 3y less than or equal to 6. You gotta switch the sign around because we divided by a negative. Y is greater than or equal to negative 2. So go down 2 and go over 3 on the x and then draw the line. Another solid line here because we have the line underneath. Let's figure out the shading. X, you can use either one. X is less than 3, less than any point. So go to this point right here. Less than 3 means this way. Less than 3 means this way. You can also use the y, it'll give you the same information. Y greater than negative 2. Greater means this way. Greater means this way. So either way, it means the same thing. It's all above the line. Well, let's take a look at the last type here. Here we have points that line a line. Do the points line the line? Well, if we're going to determine whether a point's on the line, you have to substitute. This is x, this is y. So 1.4, make sure you put that all the way in for x. Don't put it in for y. 0 is what goes in for that y. So it's going to be 0.35, 35 hundredths times by 0 equals 10 times by 1.4, and then you have to minus 14. So you do some work here. This makes 0. And over on this side, well, 1.4 times 10. 10 just moves the decimal over one space. A lot of people say 140, but that's because you forgot to move the decimal back. Well, 14 minus 14 also makes 0. So when the two numbers agree, that's when you say yes. So if you're determining whether a point's on the line, all you're doing there is just substituting. So same thing here. 9 goes in for x, negative 2 for y. So we have 1/3 times by 9, treat 9 as a fraction there, and minus 2 times by negative 2 equals 7. So 3 goes into that 9 3 times. So we got 3. Negative and a negative, those multiply to make a positive 4. And those two numbers agree. So that's another yes. Over here, we got the 6. Again, that goes in for x. Negative 5 goes in for y. And so if we go ahead and do that, opposite of x, so that's going to be a negative 6. And then plus 6 times by negative 5 all equals 24. We do some work there. This makes a negative 6 equals negative 30. Oops, not equals there, but a plus sign. Let's fix that. And then from there, we go ahead and see if that equals 24 or not. And so when we do that work, we end up with a negative 36. And sure enough, those two numbers do not equal. So that one is a no. Well, the last one here, we have to substitute the x value, which is 6, goes in for x. Y value 18 goes in for y. So we have 2/3, and then we multiply by 6/1. And then from there we have a equals 1/3 times by y, and y is 18, so I'll treat 18 as a fraction as well, 18 over 1. And then minus 2. So we'll go ahead and do some work. We have to reduce. 3 goes into that 6 2 times. Multiply across, we got 4. Over here, 3 goes into 18 6 times. And a 6 minus 2 makes 4 as well. So when the two numbers agree, that's when we say yes. So there are our answers. We're on to page 3, part 4. Actually, part 5.